This is RTP. This is RTP180.
All right, thank you, Wade, and good evening, everybody. Thank you all for coming out tonight. This is a really exciting crowd, and this, as Wade mentioned, this is a great, good context for talking about weather and climate with this heat we've been experiencing. So I am a little bit of a misleading first speaker here, though, because I am not truly a weather or climate scientist. I am a water resources engineer at RTI International, and so my specialization is, well, taking weather and climate, the atmospheric science, and applying that to estimating the impact on water resources. And then analyzing that not just from the context of the water supply, but also other natural resources, right? Our agriculture, our cities. So how does weather and climate affect our society is how we analyze this through water resources. So, weather and climate. Why should I care? Aside from, do I carry my umbrella today? Or do I wear a jacket? You'll hear a lot more on this later, but I want to talk about water. So let's go take a trip down memory lane, back to our grade school education. Remember our old friend, the water cycle. All right, so your first word of the evening, everybody. We like to call it the hydrologic cycle. All right, you can go home and tell your mom you learned a new word today. So the hydrologic cycle can really be broken down into two components, right? This is the flow of water and energy throughout the Earth system. So we have weather and climate, which is all the stuff way above us. Us humans tend to not spend an awful lot of time there unless we're in an airplane. This is where we have water leaving the Earth's surface, entering the atmosphere, fluctuating around through clouds and hitting mountains, doing all kinds of fun stuff up there. But eventually, it falls to the Earth as precipitation. And this is what we refer to, this whole class of operations, as surface processes, right? So water falls from the sky, we'll pour a bucket onto the ground. Some of it's going to go into the ground as groundwater, some of it will run off the surface as surface runoff. And this is an area where we live, right? And as humans, and what we tend to do with nature is we control things. We exert our control. I like to say we have a little bit of control here because Mother Nature ultimately does win out in a lot of these situations, right? But this is where we live. We've built our environment in these locations, our infrastructure, and so we really control a lot of aspects of the cycle here, alongside the fish and the duckies and the trees. So another term before we get too far into more of the meat of my presentation is watersheds, all right? So the rain falls from the sky, it hits the ground. Well, it's got to go somewhere, all right? The convenient thing about water is that it's very predictable, and it always flows downhill. So when we trace the flow of water, right, so this is better explained sort of from a backwards perspective. Here we have the major watersheds of eastern North Carolina. You see the triangles around here. All right, so if you're sitting in Chapel Hill, and you pour a bucket of water onto the ground, some of it goes into the ground, some of it runs off the surface into creeks. Those creeks run into rivers, and eventually those rivers form the Cape Fear River, which flows down through the hills and eventually exits at Wilmington and enters the Atlantic Ocean. All right, if we're in Raleigh, we pour a bucket of water onto the ground and it goes out through New Bern into the Pamlico Sound. We refer to these kind of geographic designations as watersheds, right? When water falls, it doesn't really go between these two locations. So if a drop of water falls in the Cape Fear watershed, it is going to fall out into the Cape Fear River. This has big implications for how we manage our water resources. So, for example, the triangle and a lot of the triangle, and particularly Durham, kind of straddle the boundaries here, right? So we have Durham, they'll be pulling in drinking water from the Cape Fear River and releasing that water into the Neuse River. So that, in effect, is transferring water in both space and time between these two river basins. For a fish, that's kind of confusing, right? Because they may be relying upon some of that water to flow down out through the basin. So these kinds of transfers allow us to affect the natural processes that are at play here. So in general, our water resources in North Carolina are, from having worked in other places across the world, my perspective is that we have abundant water resources in both space and time. What does that mean? Well, abundant water resources in space means that we don't really have any deserts in North Carolina, and we have kind of areas that are a little bit wetter than others, but it's all pretty wet. Abundant water resources in time means we don't really have wet and dry seasons, right? So imagine Seattle, all right? You have about 3 months where you can go outside and play because it doesn't rain, and then the rest of the year you stay inside and question why you live in Seattle. We don't have that. We have a pretty even distribution throughout the year. However, it's a little misleading, right? Because we look outside and it's always pretty green. And so you would think, well, it's such a wet area, we don't have droughts. But we do have droughts and we have floods because we have variability in our water supply from year to year, all right? So let's talk a little bit more about what these kind of droughts mean. And how we manage those, right? This interannual variability, we manage that through our human systems, through our infrastructure that we've installed. So one of the more obvious examples of managing this variability is reservoirs. I like to think of reservoirs as a refrigerator, but for water. All right, so buying a new refrigerator doesn't mean that you have more food. It just means you're better able to store food from time and place, right? So if you're low on food for a little bit, you can eat some later. So we're going to skip ahead a little bit because Wade tells me I don't have much time left. Climate change, it's going to be warmer, more evaporation. Precipitation, who knows? These guys are going to tell you a little bit more about it. But the big story with climate change is that we're going to have a more variable future. All right, so how do we learn to adapt to that? We do that through our behaviors, through being smarter about how we consume water, and through our infrastructure. We can add more plumbing, as I like to call it, so pipes to move water in space and time, reservoirs to hold water in between, and managing our groundwater more effectively so we have a buffer for those times of shortage. And the key word here is resiliency. So thank you very much. That was a lightning crash course in water resource engineering.